our last experiment, which is determination of iron 3 ion concentration using Beer's law. Based on the Beer's law, I mean, we have to use is a spectrometry. So we are using the spec 20 for the to perform the experiment, and is based on the absorption of the light. So when you shine the light through the sample, some of the light is going to be absorbed by the sample, and some of the light is going to pass through. So if we present 100% or for I0, the amount of the light that is going to be transmitted, which meaning passing through the sample, if it's like 90% for a sample, what it means that 10% of the light was absorbed by the solution. And what affects that, how much light is going to be absorbed? There are couple factors. One is the thickness of this tube that you're using. The length normally is like 1 centimeter. So that can be the same for all different type of solutions, different concentration of the same solution. Second factor is the concentration. The higher the concentration, because it's a colored solution, the higher the absorption of the light is going to be. And then we have this epsilon, which is a constant number. So the amount of the light being absorbed, it depends on, directly related to the concentration. The higher the concentration, the higher the absorption of the light is going to be. Absorption of the light is a logarithmic number. So it makes it easier for us if we measure the transmittance, percent transmittance, how much light would pass through, and then calculate the absorbance, because that's more straightforward. It goes from 0 to 100. So percent absorption is how much light has passed, how much was initial times 100, and it's going to be a percent value. But absorption is a logarithmic value, so that's why we use the percent, as I said. So what is this experiment entitled? We have this chemical reaction. The product is a colored product. So when we add the different concentration of the iron, we add fixed amount of the potassium thiocyanate. We weigh the same amount, consistent from one trial to another trial, and we place in the spec 20, we read the transmissions. The higher the concentration of the iron, more light is going to be absorbed. When we have all the numbers for like 5 different solutions that we make, when we have different concentration, we get the absorption, and then we calculate the absorbance of the light, and we plot a graph. This graph is known as the standard curve. When we plot our standard curve, that shows concentration, it is linear. Concentration depends on the absorbance, or absorbance is directly related to concentration. The higher the concentration, the higher the absorbance, and that's what we can see from the graph. Let's say if we use the concentration of the 2 and 3 and 4 and 5, now if someone gives us an unknown sample of iron, and it happens to be to absorb right here, if our unknown absorption is going to be this much, 0.4, then we draw like perpendicular line to cross the curve, and then we do a perpendicular line to cross the concentration line, and corresponding number from the concentration line is going to be the concentration of unknown. So we find the concentration of unknown experimentally. First, we are going to to test with the known solution, find the value for percent transmitted, calculate absorbance, plot the graph, generate this standard curve, and from the standard curve, use our unknown and find the concentration based on the absorbance. So you're going to fill these numbers, and then based on the transmittance, you find the absorbance, and you plot the graph based on these two graphs, the percent, the absorbance and the concentration. And when you have the graph, of course, you would find the concentration for the unknown solution. The unknown solution, we already know that is iron because we are adding the same reagent. We just don't know what is the concentration of the iron. And that's the end of the pre-lab discussion for this experiment, which is the last experiment for this lab manual.